Okay, so now we're ready to start looking at the floor joists for the first floor, which sit in between these two lines here in the section. And so ordinarily you could just set these out in the section, but because they run at an angle to, also they run parallel to this angled wall, it's going to be easier to start setting out the reflected ceiling plan and then transfer that up into the section. And so to begin the reflected ceiling plan, I'm going to copy the entire ground floor plan down, and so remember, a reflected ceiling plan sounds more complicated than a plan or a floor plan when it's actually no more difficult to draw because it's oriented the same way. And so the reason it's reflected is that technically if it was a true ceiling plan, then it would be a mirror image of the floor plan because you're cutting and then looking up. But with a reflected ceiling plan, you cut the walls in the same direction as a floor plan, so it should look basically the same as your floor plan. It might be cut at a higher level, but it should be oriented the same way as your floor plan. But then it's as though you've got a mirror on the floor that is reflecting what you would see above. Again, it sounds complicated when you describe it, but to draw it is much, much easier. And it all comes from drafting on a drawing board where you could just lay your tracing paper over the floor plan and draw over the top of it and imagine where the ceiling elements are projecting through the floor plan. So with the floor plan that I have here now, I can begin by offsetting from that wall that has these joists parallel. And so I think we can just assume that the spacing here, 450, starts from the wall, and if you can find any photos that show that wall, we can maybe check that. Oops. I'm sure there will be a few. No, that's where it goes to. So it's next to the roller door. So if we could see over there, it's just a bit hard to see. So I think there's a joist right up against the wall. Not that we need to have this done perfectly, but often it's easier just to do it the way it is in real life than to make up a new way. And here we go. So that's the other side. Unfortunately, that's the side with the stairs. But you can see again, that's pretty typical, having a joist right up against the wall. The joist supports the floor, the flooring, so the floorboards above, and then the beams hold the joists up. So there again, I think we can see pretty clearly that there is a joist up alongside the wall. Now the spacing is going to vary alongside that, but again here we can just say that's where the spacing is measured from.
Whatever you call it.
Herringbone struts, yeah. Or just the herringbone, yeah.
The joists,
yeah.
So they just actually fit right in there.
Yeah, exactly. Yeah. So they're like a cross bracing, mainly to give separation to the joist to maintain that spacing. Yeah. But they also do brace the structure.
Yeah.
So from this wall, so remember we can assume that the joists are 50 mil, even though they would have been built before the metric system was adopted. So they'd be 2 inches, I'd say, in reality. But that's 50.8 mil, and that's close enough to 50. So I have a joist layer already, making sure I'm on the right floor plan, which is the bottom one, and can just start offsetting 50 mil from the edge there, and put that straight onto the new layer. And then I'm going to extend that using the top wall and the bottom wall So yeah, I just under, so yeah, next to the button for trim, you've got extend. And then, well, really here, we're going to see the windowsill. So if we do cut through the windows in the ceiling plane, we might not even do that, but if we're going to do that, then you'll see the wall. Yeah, well, you'd have a line from the wall layer, so wall projection, and you'd have a thinner layer line inside. Yeah, that's part of the wall, so that you don't need to have as a joist. And so from that line that I've got for the joist, now I'm going to offset 400. So remember, it's 450 centres, but because the joists are 50mm wide, that means the gap between them will be 400. And that's fortunate because that's the new Australian standard minimum. You could do 600 in days gone by, but now has to be 450. I think it might even be less than that again. But anyhow, definitely 450 is fine here. So okay, so you can see it's going to stick out, and that's why you might have been thinking I could make a block for these, but it's not really an option. That's right, exactly, because the walls and old buildings is common. So I can offset 50 now to get the thickness. Now I don't need to keep doing offset over and over again. That's right, I just can select those two, click copy, snap to the midpoint of the first one I drew, and that's going to pick those two up, notice, with a base point that's 400 to the left of the first line I've selected. So that way I can snap perpendicular or even just to the midpoint on that joist that I already have, and just keep going along like that.
You know in Word how you can kind of do like time, power, and then you can just copy and
Yeah, an array, and you can do that in AutoCAD too. Yep. So, but when you're doing it at an angle, it's often easier just to use a technique like this with copy. So now that I've done a few, I can select a group of them. That's right, and you'll see in a few steps you'll have all of it. The skinny bit, that's a joist. Yeah. Yes, yep, that's right, yeah. Oh, and I meant to bring a few in for you. So I had them out the other day just to bring down for you. I'll bring them in next week definitely to show you. Yeah. Oh look, no one reads through the whole thing unless they have to, unless you're doing something that's that certain type of construction. But yeah, that's right. You just want to have them as reference. Okay, so notice how I'm copying in groups, so I can just, it's exponential the way it is going to increase in the number you can copy. So now, you see I've got most of them done, so I can go back to copying a smaller group. So this is where it's a bit strange, and we might want to check. So let's have a look against the stairs. Yeah, look, I don't know that that they got it right in the drawings. So having done all of that, I've now realised. Yeah, I think it is, which is good because that's much easier. Okay, so let's just say this drawing is wrong. They got the beams right, but they were wrong about the joists. So that's good to know. Okay, so at least you know how to do it if you need to do a joist at an angle like that. Yeah, I thought it was a bit strange because, look, it's up to the people who build it which side they measure to, but
will they not actually have that same problem going back the other way?
oh yeah, of course, you're going to have the issue, but here you've got these walls that are all at right angles, and it's just easier, and the stairs to go around those, that'd be tedious. So, not that old. I'd say 80s or something. Yeah. Well, oh look, it's often the hand-drawn things, because they didn't need to correlate the drawings as much, often are wrong. You can't rely on it as being an accurate source of information, just a rough guide with anything hand-drawn. And they didn't even realise that a lot of the people who did hand drawing were obsessive about getting things right, but it just wasn't possible with the technology.
Yeah.
So he'll offset from this wall, and this makes life much easier, and when we draw the section it'll be easier again. So offset 400 and then 50, so much easier. And all of this onto the joist layer. And so, oops. Okay, so as I was saying, you could use that copy method, but I suppose I'll show you array since it's at 180 degrees or in a straight line. So the Uurate All, if you haven't used that one, is a great option. It's much more powerful in AutoCAD than in Revit, especially now that they've made it parametric. So just like AutoCAD, you can go back and adjust the parameters after you've made something. So here, rectangular array is what I'll use. And so we've got to go to choose a new base point. So you can see there it's just up at a fairly arbitrary point, so I'm going to choose it from here. Unfortunately they're making it a bit confusing because I can't see which one's the original, but that is the original point there that I want to measure from. And then the spacing and the other properties you just do up on the yeah. So we don't need any rows, so the rows there I'm going to set to 1. Then the between distance will make minus 450.
So this is a dumb question, but why is it one row not? Okay, sorry.
It's from corner to corner, yeah. And then the total, so this is where the Uurate All is much improved in AutoCAD because it is parametric. So you can come back and adjust the properties afterwards. So here I'm just taking a stab at the column total. So I'll say 30 at a guess. But that's not enough. So I can come back and say instead 40. That's still not enough. So 45. That's too many. So let's try 43. Yeah. And so that's going to take it through there, so I think that should be right. Okay, so I press enter, and now you can see that if you select that, it's all one object. Yeah, it is. So it's good to have it like that when you want to adjust it, but once you're done with the adjustments, you can break it apart just by exploding it. So you've got the option to ungroup it.
Extend it to that line. Is it a quick way to extend it to that line?
No, because then they have to be different. So this only works if they're all identical.
Okay.
So now, again, once you use explode, then they go back to being just regular lines. And so here, this is again where AutoCAD is far more powerful than Revit for drafting. You can just use extend and choose the wall lines up here. Well, actually, sorry, it goes over these, so I won't select these, but I'll select just the ones at the top. I'm assuming the joists would have to go over that. Oh no, that's a void. That's a void. In fact, the void extends down, so I'll have to change this later anyway. But I'll just show you with this room as it is. So I will select those lines. Yep, that is a void. We might end up changing it to extend that void over this whole area here later. So anyway, just so you get the basic idea. Enter to finish selecting edges, and now you can select all of these joists as a group instead of clicking on each one like you would in Revit, and that saves a lot of time. So we don't need that little one in the corner, so that last one actually isn't needed. And then you can do the same with trim. So I just need a line though running along here for now, so I'll just draw a temporary line there. And then with trim, choose that line, and then you can either pick on the lines individually, or if you're happy to, select them by just crossing over them. And there we go. So that looks much neater. Got to cut a hole for the stairs. So again, with trim, you can choose the top and the bottom step, should be enough. Pick the joists. That looks pretty good. And so then it'd be a good idea to go ahead and put in the beams. Since you're doing an interiors project and you really want to, you're treating this as a finish, you want to draw it the way it looks, rather than having just a diagram showing the beams locations. So we know the beam size, having just drawn one. We can assume that the width there is the same as 180 from memory. Yep. So, okay, so looking at the underside here, you could offset these lines 90 mil. Delete the inner line. And so the layer that we have for the beams at the moment is dashed. So that really is going to be for overhead beams. So I'm going to make that over, and then make another layer, yet another layer for beams in projection. Oh, you can end up with hundreds. Yeah. Well, at least dozens, maybe not hundreds, but dozens definitely. I have seen projects with well over 100 layers though. Okay, so I've got this new layer with continuous lines, so that we can have those beams on it. And so I'll just do one. You could do the same with the others and have a go at adding in the extra beams to get a good idea of that ceiling layout. And so now with trim, select those two lines, and yeah, and just go across. So here again, AutoCAD, so much better than Revit for this sort of work, because Revit, you know, it's not designed as a drafting program. It's got the drafting tools if you need them, but they'd expect you to model this and have it show automatically in 3D this way. And there are different approaches. You've got masking as well in Revit that would achieve the same thing, but you can't trim anywhere near as efficiently as you can in AutoCAD, obviously. So, okay, so that's just to give you a basic idea. So think about the way it looks from the underside and just draw it that way. For the stairs, well, it's a bit of a funny thing. Stairs in ceiling plans are always a bit of a debatable thing, because do you show them the way they look from the bottom or the way they look from above? And there's no right or wrong answer there. You definitely want to indicate their location. Strictly speaking, it should be the way they look from underneath.
If it was opposite to that, you'd simply just make the dashed line solid and solid like that.
Kind of, but so you're not really going to see this stair from below. You're going to see the stair for the next level from underneath. So I'd just leave it like that for now and focus on, I mean, the purpose of the ceiling plan, yeah, the purpose of the ceiling plan really is to describe the ceiling and to indicate things like lighting and other services that are on the ceiling for the electricians and people like that. So, but you may have lighting that's under your stairs. And I'm actually doing a project like this right now where I've got quite a lot of detailed lighting that's on the underside of the staircase. And that has to be shown on the ceiling plan. So you've got to think about it sometimes, but in this case, again, you can just leave that for now, and it's an open stair. You're probably going to ditch it anyway, so I wouldn't be too fussy or precious about that. So that's enough to then get going with back with the section and finish that off in large part, or just for this level, and hopefully can be largely copied up to the levels above. So the joists. Right, so we know that we have a joist on the right hand side, and I could project lines up, but we know the spacing, so it's probably just easier to draw in the section view. So I've got my joists cut layer, and I will draw a rectangle from the corner here going down and to the left. So that would be, remember, minus 50 comma minus 250. And now this will be repeated identically across, and it's going to hide the stairs, but we'll worry about that afterwards. So, okay, so another layer, or maybe just to keep things simple, we can just use this. No, we really should have a layer for this. So, okay, so this is getting down to hatching. So you can see, hopefully, this should tell you how to work out your own layer names, because that's the final element usually. So if you, yeah. So the way it goes is the discipline, so whether it's architectural or engineering, even though we're dealing with structural elements here, it's still really an architectural drawing. So then the category, or the the kind of element it is. So whether it's structural or annotation, for example. Then the object type. So you're going to have many structural elements of different types. And then finally the material or the other graphics options. So whether it's cut or overhead even, things like that. Cutting, no, just cutting in your view, in your section, exactly, your plan. Yeah. Okay, so hatches should usually be very light. So either 0.18, I think 0.18 is good when you're having a hatch that's cut in section, and that way a hatch that's not being cut, that's say on a wall surface that you see behind that, you can have even lighter again.
So a hatch that you see on a wall surface behind that would be like, let's say,
as light as you can make it. Yeah, that's right. Yeah. So there, our 0.18 should be fine, and I would make the colour here a bit fainter, just so it reads different to the outline. Make that current. So even though I've called it hatch, I'm not really going to draw with the hatch tool. I'm just going to draw lines, because remember, that's right, for rough sawn timber or timber that's not finished timber, cross.
So that's your hatch.
Yeah.
Really, the timber that isn't a finish always just going to go across it.
Exactly. And so now I can make that into a block. So B, and again give it a name. So let's just call it Joist 250 by 50. Oh no, I can do that afterwards. And so with base point? No. So the base point can be almost anywhere here. I might use the corner under the floor. And convert to block, of course. Okay. And that makes everything work better when you do the array, because AutoCAD only then stores this information once, and when you're copying it or using array, it just needs to store the insertion point for each copy. So it saves a lot of memory in your file, apart from making it easier to edit. So using array, again it's got these annoying default settings, so we don't need any rows, also we need one row. Then the row spacing isn't relevant here, but then the spacing between the columns is, so that's going to be minus 450. And for this one, we might even be able to leave it as an array. So I'm going to...
Is it not minus? Have we been doing 400?
That's between the lines. So the gap between these two lines will be 400. But remember, between each corner will be 450. And then you have 50 mil for the joist, so that leaves 400. And so now I can just keep adding in numbers. You can even try stretching, but when you do that, you've got to make sure the spacing stays the same. So using the arrow, just bring that across. It's a nice way of changing it, and it's added in the extra columns and got the spacing between still at 450. And we can leave that one as an array, which is a nice thing. And then the stairs, you can trim even when it's a block. So I'll show you this. When you go to choose edges, you can choose blocks, but I'm going to press enter and just go back and pick on each line, which makes everything a cutting edge and doesn't take long to just click on the bits you want to get rid of. So this line doesn't really need to be there. Yeah. Even though I think they did show it in the section. Again, hand drawing. I just drew whatever.
But would you not really see it?
Oh, no, so there's a beam there though. So you will see the line there because of the top of the beam. So you will see it actually. So that really is now... Yeah. So that should make it clear. And then the joists are heavy, so they read as being cut, which is nice. And you could just offset 15 mil above and below those lines. And if you really want to be fussy, trim in between your columns. See how you're going for time. It's worth doing this. Yeah, so well that's from the side. So the beam has the flanges, just like we can see here. So it might seem fussy going down to this level and getting the columns to look right, but it doesn't hurt to really draw it the way it looks, and you get a much better feel for the way it's built. And these old steel structural details and approaches are really common throughout Sydney. You'll see lots of buildings, late 19th, early 20th century, have structures just like this. Yeah, the newer buildings, it's different again, much more logical in the newer buildings, but this is still a pretty good approach. This is how modern structures evolved, following this approach to building. So good to know. And so that's the joists done. And so we've got the floorboards there, and now I can start trimming back to see what's not needed for the stairs. And so then the final thing would be the good old herringbones, or herringbone between your joists. So that's a fairly easy thing to add in now, because again it will just be a block. So I'll do it going the other way though, because I don't think it goes all the way across. You can see in the section, because probably originally they weren't visible there in that section. They would be there, but just not visible in that part of the section. They might be behind the beam or something. So it's a nice thing to show though in your section, and then if you're doing it in 3D, it's a really nice thing to have in a 3D view.
So you're saying with a herring level
No, I'm just going to do it up to here, and because it's an array though, I can easily extend it later. So, there's a bit of maths involved to get the angles spot on. I'm not going to take it that far, I'm just going to do it fairly quickly so it looks right, but isn't necessarily exactly right. Now, you could make a new layer for this, but I think we can just include it as part of the joist, so I'm going to use the joist layer. And so I'm just going to draw a line from the bottom left corner up to the point just below the corner on the opposite side. So by eye, I'm bringing it down. I'm not going to bother doing a trigonometry to work out exactly where the spacing, so we're going to assume size as well.
bringing that down because of the three-dimensional size.
Exactly. Yeah. So we're going to say they're about 40 mil. They might be 35 or something like that. Yeah, or a bit more than. Well, I'm going to say they're close to 35, so a little bit more than 35 is what it would end up as. Yeah, so 38, something like that. So I'll just do that again because it's a bit tricky. So again, from this corner, I'm hovering on that point, and that's then when I bring it down, going to rely on the object snap tracking to project a line from that edge down. So between 35 and 40. And that way I can then copy that line from the end on the right up to the corner. Now you can select both of the lines and use mirror, snap to the midpoint of one of them, straight above, does the other side. And then we're just going to assume that one is in front and one's behind. So with trim, let's say the one I drew first is in front, and then you can just choose the two lines behind. That easy. So that one's a nice, quick and easy one. And again, it should be a block. So just selecting them all, B enter, and it is simply going to be herringbone strut. Just because herringbone can be a pattern in brickwork and other things. So with the base point there, I'll use, say, the corner here. Leave it on convert to block. And oh no, so I'll do pick point again. I'll use this corner. It'll work better later. So that's fine. Okay. And now again with array. Just going to put those values in. Yeah. It's off-putting, but once you get used to it, just remember to put the values in. So once I've put the spacing between the columns, hopefully using the arrow there, I can just bring it over to where I want it to stop. And that is pretty much all of that level done. Sorry? Oh, that's right, exactly, yeah. And people would have done all of this by hand in days gone by. That's why you had offices full of people on drawing boards, which have all gone and been replaced by computers now. So you want to draw as much as you can before then trying to copy that. But once you have drawn it and you think it's accurate, try copying it all, including the columns. So let's check. The upper level plans should have beams basically in the same location, and columns so as well. So even though they'll be different heights, we can copy them for the most part. And so I've selected all of the floor structure, including the columns. Copy, and I'm going to snap to the line of the level. So you can see how useful having these lines will be. So I can pick it up on one of those and snap to the next one. And now these columns just need to change. So, really good way of doing that, just to finish off, and I'll give you some time to try all of this. I'm going to measure the distance that I want to bring them up. So it is 425. Right, so firstly I want to isolate these because I've got a bit of stuff in the way. So I'm going to select them, right click, and then isolate objects. And so we've got the base that just needs to be removed, and so instead of making a new block, I'm going to simply select all of those things that are blocks and explode them. Move the just select left to right and remove those base elements. So remember, I measured to the bottom of those, so we need to bring these up 425 minus 150, which is 275. So we stretch, again left to right, and bring it up from the base point 275, enter. So they should now line up with the floor, and to check that I'm going to right click under isolate, end object isolation, and that'll bring everything back, and you can see now they line up perfectly. And from that point on you could much more easily copy those to the level.
Why is it that the lower level is the only level with the block?
Oh, because that's anchored to the concrete slab. Yeah. I doubt it would be there on the upper levels, but let's check. I haven't looked actually. Yeah, so you can see there they just project through. And so, look, I'd say they do actually connect to something below. It's a bit hard to tell.
Can they connect to...
Yeah, they probably do extend through. So even though I've stopped them there, and they'll be blocked by the joists anyway, you could even extend those lines through, but you'd have to draw new lines. You couldn't do it as part of the block.
Would they sit flush with the beam below, or would there be something in between those two?
No, they could really extend. So often they do stop the columns and start them again, and have the structure in between, sandwiched between the columns.
Yeah.
But again, it's often with older buildings done with the columns projecting all the way through, and that's an approach. These days it would all be joined together as one steel structure. So anyhow, if we extend that through, so I've just selected this edge as my boundary edge, and with extend now you can just select the line. So this is why it's good to do it afterwards anyway. So these lines we don't want because they're going to hit the joists. These would be visible, and so you just got to do it in stages. So that one again is going through the joist, but this one you can see so there we are. And now again, using trim, instead of selecting cutting edges, I'll press enter this time, and can just go along clicking on the bits to take away, and you're starting to get a really good idea then of the look of the structure. And it's a bit frustrating because for interiors you need to draw all of this. The engineers wouldn't, because they don't really care how it looks. They just need to do their calculations. But you do need to think about how it looks, and it's not a bad, interesting detail. Yeah, exactly. Yep. So your lighting and everything else can be integrated in there, and also make a real feature of it as well. So that's pretty tidy, and coming across again, I know I missed part of it here, so I didn't get the bit in between the floorboards. And there we go. So I'll give you some time to try that.